All right, hello Algebra 2. We are doing 6.2 operations with radicals. Operations meaning addition, subtraction, multiplication, and division. And now we're going to be doing that using radicals. We are very used to doing our four operations using just algebraic expressions. So we're going to start off just by thinking, how do you add and subtract radical expressions before we really talk about the radical part? We're going to talk about how you add and subtract just algebraic expressions. So when we're talking about 3x's minus 4x's plus 2x's, remember the x does not change. We are only adding and subtracting the coefficient. So remember, the coefficient is that number in front of the variable. So what we're really doing is taking positive 3 minus 4 plus 2. We have 3x's minus 4x's plus 2x's. All right, so think of x's like M&Ms, some kind of object that you're holding on to. If I have 3 M&Ms minus 4 M&Ms plus 2 M&Ms, right? Negative 1 plus 2 gives me a positive 1x. All right? Then I've got the same idea for my radical at 7. So let's just think now that my radical 7 is like an x. Okay? Here's another radical 7. That's another x. Here's another radical 7. That's an x. So 3 radical 7s minus 4 radical 7s plus 2 radical 7s is the same thing as saying 3 times x minus 4 times x plus 2 times x. Remember that x does not change, which means the radical 7 does not change. All I'm going to do is take 3 minus 4, negative 1, plus 2, positive 1. So I just get 1 root 7, which is really just root 7. Okay, square root of 7. All right, let's try a couple more. If you notice, the square root of 11 this time is constant. Well, here it is, and here it is. Here in the middle, we have a square root of 3. This is an unlike term, right? We can only add like terms. So I can take the negative 3 square root of 11 and add it to the 7 square root of 11, but the 9 square root of 3, because it's not a like term, it would be as if I said the square root of 11 is an x, so there's another x, but the square root of 3 is something different, so think of it almost like a y. You're giving it a different variable. So negative 3 square root of 11 plus 7 square root of 11 gives me 4 square root of 11. However, I cannot combine that with the 9 root 3, so I'm going to leave that separate, and there it is. My 2 separate pieces. I can't combine it any further. So from this page, we just want to make sure that when you are adding and subtracting, we have a common radical. Remember we were saying that this number inside here is the radicand. We want to make sure that that is the same every single time that you add. If it's not the same, I can't combine it because it's not a like term. So we can even give ourselves a little star on your notes. Radicands must be the same. Okay? So you can bet that we are going to do some examples where the radicands are not the same and see if we can actually still add them. Radicands must be the same. All right. So let's look at a few harder examples. Again, pause the video as you need to. Looking at this one, we have the square root of 12 and then the square root of 3. Obviously, these are not the same. However, what we do want to notice about the square root of 12 is that it is not simplified. So we want to make sure that we simplify first. Okay? So the last 3 that we looked at, they were already simplified. So I'm going to say step 1, we are going to want to simplify this radical. So the square root of 12, we did this just today in class. Square root of 12 is really the same as 4 times 3, the square root of 4 times 3. And then I can keep the 5 root 3 over here. This one is simplified. Remember, 3 is a prime number. I cannot break 3 down any further. So this term is simplified. Here, I have the square root of 4 times the square root of 3. Well, the square root of 4 is really 2, right? Because 2 times 2 makes 4. So I can write it as 2, and then square root of 3 is going to be left on the inside. Then I can bring down this 5 root 3, and now I actually have the same radicand. So step 2, I'm going to actually combine like terms. So 2 root 3 minus 5 root 3. Remember, I still have the root 3. That doesn't change. And I'm going to subtract the coefficients. So 2 minus 5, that gives me negative 3. And that winds up being my final answer there. Let's see if we can do the same thing for number 5 here. I have a root 5, square root of 5. 5 cannot be broken down any further, but 20 can. Okay, so again, step 1, I'm going to simplify first. And let's rewrite. So square root of 5 is the same, haven't done anything to it. Plus 2 is my coefficient. I'm going to try to break down 20. 20 can be written as 4 times 5. And then minus square root of 45. Okay, 45, I'm thinking 9 times 5. Now, again, square root of 5 I can't do anything to, so I'm just going to keep it with me as I rewrite. However, here I have a 2 on the outside, so I'm going to keep that as my coefficient. But the square root of 4 is 2, so I'm going to pull out another 2 for this 4. The square root of 4 is 2. There we go. And then the 5 is left on the inside. For here, 9, the square root of 9 is 3. That comes from 2 3's. And then 5 is left on the inside. So now what I really have is the square root of 5. Any number that you pull out, remember these are all factors. They're multiplying by each other. So 2 times 2 makes 4 root 5. And then I have minus 3. Woo! Let's get rid of that. Minus 3 root 5. Okay. Now, voila, I have the same radical, which means step 2, I can actually combine my like terms. And if I have 1 root 5 plus 4 root 5s, that gives me 5 root 5s. Remember, my root 5 does not change. 5 root 5s minus 3 root 5s, that leaves me with 2 root 5s. There's my final answer. Let's try a couple more. Square root of 72, again, step 1, let's try to break these down. So I have square root of 72 comes from, let's do 9 times 8. How's that? We'll work with that first. 27 you can write as 3 times 9. And then 32, I can write that as, how about 16 times 2? Again, it doesn't matter if you guys use different numbers to break these down. They'll always wind up being the same at the end. So as long as you simplify completely. Okay, I can actually continue to break down 9 times 8. So I'm going to go ahead and let's rewrite this as 3 times 3 for the 9. 8 is 3 2's. Just want to make sure I haven't missed anything. This one's okay, but I can also rewrite this if I wanted to. So 3 for this 3, and then 3 times 3 makes 9. And then in addition to that, I will have the 16, so that's 4 times 4, and then I have this additional 2. Okay? Ooh, there we go. And this is a 4. All right. So now, let's go ahead and pull out my pairs. So again, the square root of 9, because that's 2 3's, is 3. I pull out 1 3. 8 has 2 2's in it. So I pulled out that 3. I'm going to pull out a 2 as well. And then I'll have a 2 left on the inside. I have a pair here. Square root of 9 is 3. So I'm going to have 1 3 left on the inside. And then I have 2 4's. So 4 and a 2 is left on the inside. So what I'm doing is 3 times 2. Any numbers on the outside, again, those multiply. They are factors. So I have 6 root 2 minus 3 root 2, 3, and then plus 4 root 2. I have 2 common terms, so when I do my second step and I start to combine my like terms, I can put together the 6 minus, can't do those two, 6 root 2 plus 4 root 2. I can do those, so I get 10 root 2. And then the root 3 has to stay separate. Okay, and that winds up being my final answer. All right, so now for number 7, I'm going to use what I just did up here. If you notice, guys, here's a root 8, and I did root 8 right here. Root 8 was 3 2's. So if I have 3 2's, when I do, I'll draw a line here. I'm doing a separate problem now. Number 7. So since I know that 8 comes from 3 2's, I knew that that was 1 2 coming out and then 1 2 stuck on the inside. So I have this 3. I have to keep it. There it is. But for the square root of 8, remember that's 2 times 2 times 2. So I can pull out one of those 2's because I have one pair. And then the 2 is left. There's one more 2 left on the inside. So that's 3 times 2. And then 32 I also broke down already. 32 was back in this problem. So that was 16 times 2, which means the 4 can come out and the 2 can stay on the inside. So what I'm really looking at is 6 root 2 plus 4 root 2. And that, again, if I do my step 2 and I combine my like terms, I can get 10 root 2. Okay? Oop, there we go. There it is. All right, so this is addition and subtraction. Our keys for addition and subtraction are that the radicand must be the same. So I must simplify, try to get it so my radicands are the same, and that way I can combine like terms. All right, so our second topic is going to be multiplication. When you guys are multiplying, remember that any term that multiplies by x minus 3 in their parentheses, we have to distribute. So really this is going to give us 2x squared minus 6x, right? So we'll do the same thing here. If we have x plus 4 times x minus 8, this is a FOIL. So we will have x times x squared. We'll do x times negative 8. We have your coefficient and your variable. 4 times x is 4x, coefficient and variable. And then we wind up doing, let's see, where did I just go? I did x times x. Oh, and I have to do so I did my inside and my outside. And now I've got to do the 4 times the negative 8. So that's negative 32. I can usually combine like terms. So I wind up with x squared. Negative 8x plus 4x is negative 4x. And then minus 32. So again, this is just rewriting what you guys were given originally, but you're rewriting it by multiplying it out. And then remember this one, if you have x plus 7 squared, that really means that you have x plus 7 multiplied by itself. So I have x plus 7 times x plus 7. So in order to actually simplify this one, this is also a FOIL question, right? So I'd have to do x times x times 7. So that would be x squared, oh goodness, plus, I'm connecting today, here we go, 7x, and then we have 7 times x. Oh boy, does not like that. Okay, let's try that one more time. 7x, and then we have 7 times 7, so 49. Again, your common terms we can combine, so we wind up with x squared plus 14x. We are going to do the exact same thing with radicals. So think about this while we are doing our next example. If you want to think about how we multiply radicals, we have square root of 5 on the outside of the parentheses. We are going to have to distribute it to whatever is on the inside. Remember, they're separated by a plus or a minus. That separates terms. So I have to make sure I distribute to each term on the inside of the parentheses. 3 acts as my coefficient. Square root of 5 is going to have a coefficient of 3. This is multiplication, 3 times root 5. We're also multiplying square root of 5 times square root of 2. Since 5 and 2 are both radicands, they will multiply and they'll go on the inside of the radical together. So 5 times 2 gives you radical 10. 3 does not join the radicand. It does not go on the inside of the radical because it is a coefficient. It's a whole number, whereas the square root of 5 is not a whole number. All right? Let's try another one. Square root of 6 times 3 and times negative root 2. So again, 3 acts as the coefficient. Square root of 6 stays by itself. Minus, and then 6 and 2 are both radicands, so they will both multiply, and they will go on the inside, make 12. What you do want to check and what we'll practice in class is that 12 is not simplified. So you do want to go ahead and break down 12 and try to rewrite it. See you guys.